All right, let's do this practice together. Okay, so this probably the first time you have to come up with the molecular structure from just a proton and NMR. So maybe go with me. You can try on your own too. All right. Or you can just go this with me and you practice them more on your own. All right. The proton NMR won't give you like the a direct structure. You kind of have to like kind of come in conclusion. What's it look like? How does it work in here? All right. So let's do this together. All right. First off, if you have a molecular formula, you can get a DOU. Okay. So what's the DOU in here? C9H10. If you do DOU, it's gonna be DOU of 5. Okay. So think first. What does DOU of 5 mean? What's the possibility? Well, multiple million double bonds, triple bonds. I mean, just too many combination. But hey, let's think about this though. Read at the top real quick. If you don't read it, okay. The following compound is a ketone. A ketone has C double bond O, and that's DOU of 1. Now that's 1 already. All right. Now what else? Well, that's still a lot. DOU of 4 is a lot, but we have the signal about 7 to 8. What does this mean? What a signal about a proton of 7 to 8, that's a benzene ring, right? And the one benzene ring, so 3 triple bond, 1 ring, that's 4. Okay, so the other 4 is actually a benzene ring. Yep, that's it. You kind of get half of the structure now. All right, and then the rest is going to be where to connect them. All right, what else you can do? Well, we can try integration. All right, so we have 10 protons total. Looks like I'm going to go with 2 and 3. And that 2 and 3, maybe that's 10, right? So this is the height, same height here, 2, and the 3 a little bit higher, so right there. All right, so okay, the integration. So we have 2H, 3H, 2H, 3H. All right, let's now focus on just the start from the left side. Okay, so as I mentioned earlier, so this compound contains a benzene ring. All right, this benzene has 5 protons. What does it mean? Well, if you see a 5 proton, you have to automatically come up with this is a mono substitute benzene. If you don't get what I say, think about it. In a regular benzene, how many protons are there on a benzene ring? There's 6 protons, right? On the benzene, 6 protons. But look at the integration. There are 5 protons total on this benzene ring. Something has replaced that 1 proton. So you end up with a mono substitute benzene. Look like that. 1, 2, 3, 4, and 5. Okay? Could it be di-substitute benzene? Auto, meta, para, doesn't matter, but di-substitute benzene. No, it's not. This is 4 protons. 1, 2, 3, and 4. 4 protons. Okay? All right, so on the left side, we know so it's mono substitute benzene. All right? So the NMR spectrum doesn't tell you exactly, hey, this is mono substitute benzene, but it gives you integration. You should be able to come up with this is a mono substitute benzene. All right, so it gives you like information indirectly, basically. All right, so we're going to move on to the peak at about 3 ppm. All right, so we know this is 2H. The spin multiplicity, say there's a quartet, so that's neighbor. But before we got neighbor, so this is a CH2. If you look at the chemical shift, it's about 3. Regular CH2 is supposed to be above 1, right? That's all the proton on a carbon, so chemical shift is about 1. But right now, something de-shielded to 3. Well, you have to think what could de-shield it. Now I'm gonna put X right there for now. Okay, and on the right side, so this is 3H, this is CS3. Okay, so we know the CS3. Okay, all right. Now, what else we know? Look at the spin multiplicity. The spin multiplicity said we got this CH2 got 3 neighbors next to it. It's a quartet, right? Which means it got 3 neighbors. But this CS3 got 2 neighbors. A triplet got 2 neighbors. Well, 3 neighbors and 2 neighbors. These guys are connected. You have an ethyl group. There we go. Okay. Maybe take some time. Think about what I just said. All right. So the spin multiplicity takes some time to like to come into conclusion. You have to practice a little. But I'll say one more time. All right. If you look at the spin multiplicity, so we have 2 CH2 right here. This CH2 got 3 neighbors, and this CH3, a triplet, got 2 neighbors. Well, 3 neighbors, 2 neighbors, they are connected, and they're next to each other. All right, so what we got, so we have a benzene ring, we have an ethyl group, it's a ketone. Let's count number of carbons real quick. So 6, 7, 8, 9, we have 9 carbon total. All right, so it looks like we have all the carbons and all hydrogen in here. Now we have to put them together. Can I do so? Let's say if I put them like this, I got two options. Right, ketone, both are ketone, got a benzene ring, got a benzene ring, right? Got two carbons, so they all have 9 carbons. Now, which one though? Which one's correct? Well, let's do this. Start with the blue proton. Okay, so what is spin multiplicity of this blue proton? 3 neighbors, quartet. All right, and the red one, how many neighbors? What's spin multiplicity? 2 neighbors, a triplet. That quartet and triplet, that's what we saw. But if you do like this, some people do like this. So how many neighbors are there? There's no neighbors, right? This guy has no neighbors, so a singlet. And the other one on the right side, the proton right here also has no neighbors, also show up singlet as well. But what do we actually have? We have a quartet and a triplet, quartet and triplet. So it's this guy. There we go. Okay. All right, you just have to practice it. Look up what I posted or the practice for you. Okay, keep practicing, and this part will come a little bit more easier over time. All right.